Hello students, let's get to work. This is 8th grade math, unit 3, lesson 8. This is a very important lesson. We are learning the equation y equals mx plus b. Well, in our previous lessons, we had the equation y equals mx, but we called the m a k. Do you remember the proportional constant k? Well, another word for that k is m. The proportional constant is also the slope of a line, which we call m. So basically, m and k are the same. The slope of the line, the proportional constant, the rate, the ratio, whatever you want, they're the same. But now we're putting on a plus b. In our previous lessons, we've been having graphs that do not start at the origin. They have some y-intercept, and that's what this plus b is. The b is the value of the y-intercept. So that's what you're going to learn in today's lesson and from here on out. The y-intercept is b, and the slope of the line is m. Okay, so let's warm up for this. First, look at this graph here and read the directions. The diagram shows several lines. You can only see part of the lines, but they actually continue forever in both directions. So just imagine this line's going on forever, and this line is going on forever and ever. And it asks you, which lines are images of line F under a translation? Okay, not rotation, not reflection, only translation. Translation is just moving in one direction or another with no rotations. So here is line F. Which line shows a translation of line F? If it is a translation of line F, you know it's going to have the same slope because there'll be no rotation. So I'm going to make line F here a little bit bolder to see. Okay, where are others lines with the same slope? How about line H? Look at that. It appears to have the same slope. So does line I. These appear to have the same slope. Now, lines that do not look like a translation are lines J, because it has a totally different slope, so that would be a rotation. Whoopsie, I don't want that tool. I wanted to show that looks like some rotation, but we are not looking for rotations. And then line G also has a different slope of the line, so that shows some kind of rotation. Okay, go ahead and check the boxes. Which lines are images of line F under a translation? Okay, keep going. We have the same picture again. For each line that is a translation of F, draw an arrow on the grid that shows the vertical translation distance. Okay, let me draw those translations again. The ones that look like a translation have the same slope, so they've not been rotated. H, F is our original line, don't forget, and I, they have what appears to be the same slope. Now draw a vector or an arrow that shows, draw an arrow on the grid that shows the vertical translation distance. Okay, so from line F, I'll just pick any point here and go straight up to H. So what is the vertical translation distance? Count the units here. Okay, it's a little less than this line. So 1, 2, wait, I'm doing this wrong. It's a little over the line. There we go. 1, 2, 3, 4, 5, 6. It's 6 units. H is 6 units up from F. Okay, and then how about I? Oh, look, I'm going to be a little smarter this time. I'm going to get a point on the line to help me count. 1, 2. It's 2 units down. Should I say negative 2? That's 2 units down, and this is going to be positive 6 because it's up 6 units. Okay, we did it. Okay, keep going. Now, what this teaches you is that you can translate a line up or down by some number of units. A plus value, like +1, that would be moving the line 1 unit up. And -1 would be moving the line one unit down. Don't forget that. That's really important because now that we're using y equals mx plus b, and b is the y-intercept, this b shows you how many units up or how many units down, like this, 6 units up or 2 units down, okay? That's why I want you to look at that. Now let's keep going. Let's look at a problem where it starts at the origin and then compare that to a problem where it doesn't start at the origin. So the next problem has 2 graphs and they're the same, and we're going to fill them out, but in a different way. Diego earns $10 per hour babysitting. Assume that he has no money saved before he starts babysitting and plans to save all of his earnings. Graph how much money, Y, he has after X hours of babysitting. Okay, so he gets $10 per hour and he starts with no money. So after 1 hour, he has $10. After 2 hours, he has $20. After 3 hours, he has $30. And I'm really good at this, so I'm just going to skip ahead. After 10 hours, he has $100 right there. And then draw a line. It starts from the origin because he had no money to begin with. And if you have done this correctly, your points lie on a straight line. Okay, now imagine that Diego starts with $30 saved before he even works, before he starts babysitting. On the same set of axes, graph how much money, Y, he would have after X hours of babysitting. It says on the same set of axes, so I wonder why they give us another graph. I'll delete that. On the same set of axes. Okay, I'm going to change my color. Now he has $30 to begin with, so you start right here. And he gets $10 an hour, so after 1 hour, he's going to have $10 more, $40. After 2 hours, he has $10 more, $50, $60, $70. And how much he has keeps on increasing. How much will he have after 10 hours? Well, he started with $30 and then add on 10 hours of work times $10 an hour. So you get $130 after 10 hours of work. So here's my 10, we'll go right up here. If I have done this correctly, there is a straight line. Right there. So do you see what we have here? One of the graphs starts at the origin, 0, 0. But if you already have some money in the bank, you don't start at the origin. The line translates up. See how this line translates up? How many units up is that? It is from 0 to 30. That's how many units this line translates up. 30 units up. Does that now give you an idea why we showed this? How many units up do these lines translate, up or down? Okay, let me read on about that. It says, compare the second line with the first line. How much more money does Diego have after 1 hour babysitting? How much more money does he have? Well, in the second line, he started with $30 before he even worked. So let me write that down. In the second line, he started with, oopsie, not 43, that's supposed to be a $, 30. In the second line, he started with $30, and after working 1 hour, after after working 1 hour, he has $40. You know what? I took my computer outside, and I see that it's really slowing down my typing speed to be laying in my lawn chair. So, he has $30 more in the second line. Make sure that this makes sense to you. Have you drawn the graph for yourself? Can you see that anywhere between these lines, there's a $30 difference? Anywhere between these lines. Okay, let's keep going. Now, in 2 hours, how much more money does he have in the second line? After 2 hours, he has $30 more. It didn't change. How much more he has doesn't change. And after 5 hours, okay, well, look at the graph. If you don't believe me, look at the graph. Okay, after 5 hours, here, how much more money does he have in the second line? Look at the graph right here. Yeah, same thing. He went from this much to this much. Everywhere between these lines, there is a difference of $30 because that's what he started with in the second line. He already had $30 in the bank. Okay, so go ahead and type in your answer for 5 hours right here. And then how about for X hours? How much more money does Diego have in the second line after X hours? Okay, well, you get the point, right? No matter how many hours it is, he'll have $30 more in the second line. So I'll just write it like this. After X hours, he has $30 more in the second line. Okay, let's write an equation for each line. Okay, right here, write an equation for each line. Well, in the first line, the amount of money he has equals only what he earned per babysitting, which was $10 times X number of hours. But in the second line, so can I call that Y2? I don't know. In the second line, he starts with $30. And then on top of that, he earns $10 per hour times the number of hours. So there is an equation for each line. And I hope right now you have a ding, 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 aha moment, whatever you want to call it. Look at the equations of these lines. The first equation is y equals k, which is our rate, times x. And the second equation here, this is y equals, and I'm going to change the order here, the rate 10, k times our x, plus some initial amount he already had, $30. We're going to call that B. Remember, that is B, the y-intercept. So I'm going to write that in here, B. Okay, I'll let you guys catch up while I pause this video.